In this section, let's continue with part 5. Let's get the code we used from last section and paste it into Eclipse. Fix the package. Okay, this is a program we used last time. In this program, the GUI initialization code is called from the event dispatch thread instead of from the main thread. The main thread is it's only start the program, then it submits a runnable to the Swing event queue so that event dispatch thread can later initialize the class and in the constructor initialize the GUI. In this program, we also created a timer. Whenever the timer tick a cycle, the J panel is added as an action listener. And in the action performed method, we update the location of the enemies. Again, this code are called from the Swing event dispatch thread. Those state variables are not shared among multiple threads. They are only used inside the Swing event dispatch thread. So we already guaranteed the initialization safety with static or final or volatile. So those objects is published safely. In this section, we will improve the code. See those location updating code? They may take extra long. For example, you have a large collection of the locations, or in the future, you update your code. You can get your locations from the GPS device or from the internet or from the database. In that case, your code need to wait for the I/O, and it could take extra long than you really want it. In that case, if your code haven't finished, the event dispatch thread cannot process other events. Therefore, the GUI will freeze. To avoid that, we need to run those codes in a separate thread other than the event dispatch thread. How we do that? We create a SwingWorker thread. So public class, let's say animator extends SwingWorker, and the return type we don't care, and the intermediate result we don't care. And here import, then IDE will fill the boiler code for us. Okay, what do we do in doing background? We first check if anybody canceled. Okay, if nobody cancel this future task, then we do our business. First, we thread snip, snip delay. After a cycle, we update our locations. Okay, now we have a SwingWorker handle the heavy lifting. Next question is how we get it started. We need a JButton. Let's add a JButton. Private static final JButton. Start button equal new JButton. Let's say start. Let's fix the import. Now, by using static final, the JButton is published correctly. Even though the reference of start button is final, we can still change its state. We can set text as start. And we can set the action command as start. And we need to add ActionListener as this. So besides the timer, the JPanel also is ActionListener of start button. Finally, we add the start button to the JPanel. Now we have the start button, which generates a start command if we press it. Now in the action performed, we need to tell if the action is came from the timer or the JButton. So we check the action command. If it is equal to start, we know we press the button. If we press the button, then we start the animator. Okay, we don't care about the return type. The start button, after pressed, we need to disable it. And we make it invisible. Okay. Again, the repaint is called from the event dispatch thread. Let's analyze background thread a little bit. The only state variable shared is this empty. Okay. So the empty is used in two threads, the event dispatch thread and the SwingWorker thread. And since the monitor vehicle tracker is thread safe, so we can share it without worry about racing condition. And we know by using volatile keyword, it is published correctly. Let's go to check the chapter 3. For mutable objects, it must be safely published. We use volatile to achieve that. And it must be either thread safe or guarded by a lock. Yes, we checked that. It's thread safe. How about those other state variables? Those state variables are only used inside the event dispatch thread. They are not shared. So by declaring them as static final, we publish them safely. So we have the initialization safety. When you start to use them, they are guaranteed to be initialized correctly. So that is good enough for only used in the event dispatch thread. Okay, enough of talking. Let's run the program. Let's press the start button and shoot those squares. Move and shoot and hit you. Now I'm dead. Okay, this is a program using the background thread. Let's go back. I need to see what kind of a